All right, in this video, I'm going to talk about a couple different ways of representing waves, and then I'm going to use those ways of representing waves to talk about what diffraction, reflection, and refraction are. So the main way we're going to use in this unit to represent our waves is called a wavefront diagram. A wavefront, imagine this is a wave then, shows us in two-dimensional space, like a top-down view, where the crests of the waves are. So here, 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 but if I'm looking at it from top down, I just represent them by lines, like this. So imagine we're at the ocean here, here's the beach, and the waves are rolling in, this way, and these are the tops of the waves that we're seeing, and we're maybe like in a helicopter or something like that, looking down on the beach. In this case then, this distance would be the wavelength, and so the wavelength is nicely represented on these wavefront diagrams as the distance between these two crests, or these two lines. This here could be called a ray, and a ray is the way that we represent the direction the wave is traveling in. So these waves are all coming into the beach. This is the top of the waves, and they're all going from left to right as I've drawn it. And somehow we are flying above the beach, looking down on it, only seeing the top. So you can imagine the bottom of these waves, or the troughs, would be at these locations. And sometimes with wavefront diagrams, we want to show those troughs, and other times we don't. So we'll sort of do that sometimes and not do it other times. So that's what a wavefront diagram is. Now let's use that to look at what diffraction, reflection, and refraction are. First of all, diffraction. Diffraction is when a wave runs into a narrow opening, and that wave on its way out of the narrow opening will often come out in a slightly more circular way. So here are waves coming in, they go into this little barrier, and when they come out, diffraction means that they come out and that wave spreads out in a circular pattern, having gone through that narrow opening. So the wave doesn't just come out, but it comes out. It comes in with a uniform direction, and it comes out, and it's sort of spreading out in all of these directions. Again, these are our wave fronts. These are our rays. We see that we had a common direction, and we're spreading out into all different directions. So that's diffraction. Refraction is when a wave moves from one medium to another medium and changes direction through the barrier. So imagine maybe we have deep water here and shallow water over here. And from the previous video, we should know that in deep water we have waves traveling a little bit faster. Excuse me. And so we have these waves coming in like this, with a fairly long wavelength because they're traveling fairly quickly. And then in the shallow water, where they're going to have to go slower, their wavelength decreases. And when I try and draw this with a decreased wavelength, what I see is that my wave changes direction slightly. My wave came in this direction, and it left in this direction. So it moved a little bit more straight through the shallow water where it's going slower. This would be faster. Here we can see my wavelength is large, and in my new area, my wavelength is small. So to accommodate that change in wavelength, we get a slight change in direction. That ray isn't drawn all that well. Maybe it should be more like that. See, so if we imagine it was that far away from the normal in the first place, and now it's only this far away from the normal, that wave has changed directions when it went from one medium to another medium. That's refraction. Finally, reflection is when a wave hits a barrier of some sort. So here comes our wave in. And that same wave is going to come back out, and it's going to come back out at an angle that's the exact same as the angle that it came in at. This is a little hard to do, so I'll try and do this here. Something like this. So my initial waves come in, that's this guy. right? These three. Those are my incident waves. They hit the barrier, they bounce back off, and then they come back out. So these guys are incident. And these guys here are the reflected ones. If I were to draw my rays, I show my ray coming in, and then it bounces and it comes out. And the angle that it goes in and out at, in, out, the angle of reflection, theta in and theta out, are the exact same. So that's what reflection is. Refraction when we go from one medium to another. Diffraction when we go through a small barrier. And that's how we can represent them all using wavefront diagrams.